The evolution of traffic control is a fascinating journey that mirrors the rapid development of modern cities, the growth of populations, and the rise of motor vehicles. It's a story of how humans have adapted to new transportation challenges through technological innovations, administrative changes, and global cooperation. To fully appreciate where we are today with traffic control systems, it's essential to explore where it all began, what challenges arose along the way, and how we've transformed roads into the organized, regulated spaces we know today. Early beginnings, a world without traffic control. In ancient civilizations, the concept of traffic as we know it didn't exist. Roads were rudimentary and mainly used for walking, carts, or animal-driven vehicles. There was little need for formal traffic regulation because vehicles were slow and populations were smaller. Ancient Rome, however, provides one of the first glimpses into organized traffic management. The Romans built extensive networks of roads, some of which are still in use today. Roman roads were marvels of engineering, designed to connect various parts of the empire. As cities grew denser, so did the need for some form of control. Even though the ancient Romans had no cars, they had to manage traffic in cities like Rome, where wagons and carts clogged narrow streets. At times, laws were enacted to limit certain vehicles during busy hours. This was one of the earliest examples of traffic regulations aimed at reducing congestion and ensuring smoother movement within urban areas. The Industrial Revolution and urbanization, the birth of traffic problems. Fast forward to the 19th century, the world began to change dramatically with the onset of the Industrial Revolution. This was a time of enormous social and technological upheaval. As factories sprang up, people moved to cities in large numbers, and urbanization accelerated at an unprecedented rate. With this surge in urban growth came a huge increase in road usage, horse-drawn carriages, bicycles, and by the late 1800s, the very first automobiles began to appear on city streets. Cities, originally designed for much smaller populations, were ill-equipped to handle the growing volume of traffic. In these early days, there were no traffic lights, no road signs, and no laws governing the flow of vehicles. Accidents were common, and pedestrians, carriages, and cyclists competed for space. Something had to be done to organize this chaos. One of the first forms of traffic management was the introduction of traffic officers in major cities, particularly in the United States and Europe. These officers would stand in the middle of intersections and manually direct traffic, using hand signals to control the flow. It was a slow and often dangerous job. The need for more formalized traffic control became clear as the automobile industry exploded. The first automobiles were luxury items, but by the early 20th century, companies like Ford revolutionized production, making cars affordable for the average person. This led to a massive increase in car ownership, especially in cities. Roads were congested, accidents were frequent, and traffic jams became a daily occurrence. The birth of traffic lights, a pivotal moment in traffic control. One of the most important inventions in the history of traffic control came in 1868, when the world's first traffic signal was installed in London outside the Houses of Parliament. This system, designed by railway engineer J.P. Knight, featured semaphore arms during the day and red and green gas-powered lamps at night. The lamps were manually operated, and while the system was innovative, it had some flaws, most notably an explosion caused by a gas leak that injured the policeman operating the signal. The first electric traffic light, which more closely resembles today's systems, was introduced in 1914 in Cleveland, Ohio. It was a simple red and green light with a buzzer that warned drivers when the light was about to change. This new system was a major step forward in automating traffic control, and other cities around the world soon adopted similar technologies. In 1920, Detroit added an innovation that would later become standard worldwide: the three-color traffic light. A police officer named William Potts is credited with creating this system, which added a yellow light to indicate that drivers should slow down and prepare to stop. This three-color traffic light system spread rapidly across the globe and became a staple of traffic control in cities of all sizes. Traffic signs and road markings organizing the chaos. Traffic lights weren't the only invention helping to control the streets. The rise of motor vehicles also necessitated the development of road signs and markings. Early road signs were often inconsistent and varied widely from city to city, and even country to country. This lack of standardization created confusion for drivers, especially as travel between regions became more common. In the early 20th century, countries started to collaborate on creating standardized road signs. One of the first international agreements was reached in 1909 at the International Road Congress in Paris, where countries agreed on 4 basic road signs: a bump, a curve, an intersection, and a railroad crossing. These signs were simple, but they laid the groundwork for more complex systems of signage that would come later. Another major development was the introduction of lane markings. Lane markings were first used in the United States in 1911 after a tragic accident led a Michigan official, Edward Hines, to propose painting a line down the center of the road to divide traffic. This simple idea of dividing lanes has become a fundamental part of road design worldwide. Mid-century advances, the rise of traffic engineering. As cities continued to grow and car ownership expanded, it became clear that traffic control required more than just signs and signals. Traffic engineers began studying how to manage traffic flow more efficiently. One of the most important developments in this period was the use of traffic studies to understand patterns of movement within cities. These studies led to the development of better intersection designs, roundabouts, and the synchronization of traffic lights to create smoother traffic flow. In the 1950s and 1960s, many countries, particularly the United States, saw a huge expansion in highway construction. The interstate highway system started under President Dwight D. Eisenhower in the 1950s, revolutionized long-distance travel, and created new challenges in traffic management. These highways were designed to move vehicles at higher speeds, which required new types of road signs, barriers, and traffic control systems to ensure safety. At the same time, cities began experimenting with new technologies to better manage traffic. One of the most important innovations was the introduction of computer-controlled traffic lights. In 1963, the city of Toronto implemented the first system of this kind, which used computers to control the timing of traffic lights based on real-time traffic conditions. This was a major breakthrough as it allowed cities to adjust traffic control systems dynamically, reducing congestion and improving traffic flow. The era of automation. Intelligent traffic systems. As we moved into the late 20th century, the rapid growth of cities and increasing car ownership meant that traditional traffic control systems were becoming outdated. Manual control and even early computer systems couldn't keep up with the complex demands of modern urban traffic. This led to the development of intelligent transportation systems, ITS, which use a combination of sensors, cameras, and computers to manage traffic in real time. One of the key components of ITS is adaptive traffic control. Unlike traditional traffic lights that operate on a fixed schedule, adaptive traffic lights can change their timing based on current traffic conditions. These systems use sensors embedded in the road to detect the number of vehicles at an intersection and adjust the lights accordingly. This has led to significant reductions in traffic delays and improved fuel efficiency as cars spend less time idling at red lights. Another major development in traffic control is the rise of GPS and navigation apps, which allow drivers to avoid congested areas by providing real-time information about traffic conditions. These apps use data collected from millions of users to map traffic patterns and suggest alternative routes. This has been particularly useful in reducing congestion in cities, as drivers can make informed decisions about which routes to take. The future of traffic control, automation, and beyond. Looking ahead, the future of traffic control is set to be shaped by even more advanced technologies, particularly the rise of autonomous vehicles. Self-driving cars have the potential to revolutionize traffic management. These vehicles can communicate with each other and with traffic control systems, reducing the risk of accidents and allowing for more efficient use of road space. Autonomous vehicles could also lead to the development of new types of traffic systems that don't rely on traditional road signs and traffic lights, as cars would be able to navigate and regulate their own movement. Smart cities are also part of the future of traffic control. These cities will integrate advanced technologies such as artificial intelligence, the Internet of Things, IoT, and big data to manage not only traffic, but also other aspects of urban life. For example, smart traffic lights could communicate with autonomous vehicles to create a seamless flow of traffic, while sensors placed throughout the city could monitor traffic conditions and adjust traffic control systems in real time. Another exciting possibility is the use of drones and other aerial vehicles for traffic monitoring and control. Drones could provide real-time aerial views of traffic, allowing city planners and engineers to better understand traffic patterns and develop more effective solutions to reduce congestion. The human element. balancing technology with policy. While technological advancements are critical to the evolution of traffic control, it's also important to recognize the role of policy and human decision-making. Traffic control is not just about technology. It's also about how cities are designed, how roads are built, and how people interact with these systems. As cities grow and traffic becomes more complex, urban planners and policymakers will need to work closely with engineers and technologists to create systems that are not only efficient but also equitable. There is also a growing awareness of the environmental impact of traffic. Cities are increasingly looking for ways to reduce car usage and encourage more sustainable forms of transportation, such as cycling, walking, and public transit. Traffic control systems of the future will need to be flexible enough to accommodate these changes in transportation behavior while still managing the flow of vehicles. Conclusion: a journey from simplicity to complexity. The evolution of traffic control is a story of how humans have adapted to the challenges of modern transportation. From the simple traffic signals of the 19th century to the advanced intelligence systems of today, traffic control has come a long way. As we look to the future, the integration of new technologies such as autonomous vehicles and smart city infrastructure promises to further revolutionize how we manage traffic. However, it's also a reminder that traffic control is not just about technology. It's about people, policy, and the need to create cities that are safe, efficient, and sustainable for everyone. This long and complex history shows that while we've made great strides in managing traffic, there is always more to learn and improve upon. The future of traffic control will likely be a blend of human ingenuity, cutting-edge technology, and thoughtful urban planning. And as cities continue to grow, the evolution of traffic control will remain an essential part of ensuring that people can move safely and efficiently through the urban landscape.